In this question, we have to determine the resistance offered by this circuit when it is at resonance. Now, at resonance, the impedance offered by the circuit is purely resistive. Okay. First, we will write down since it's a parallel circuit, we will take the approach of writing down the expression for admittance. So, admittance Y is equal to there is a capacitor in parallel with the series combination of resistor and an inductor. So it is 1 by j omega c. So it is j omega c plus 1 by the impedance of this series RL circuit. Okay, so that is 1 by R plus j omega L. So this is the admittance of the circuit. Now, what we have to do is we have to rationalize this denominator. Okay, we have to make this real. So for that, y is equal to j omega c plus we are multiplying the denominator and numerator by r minus j omega L. So it will be r plus j omega L into r minus j omega L. The numerator it is merely r minus j omega L. So that is equal to j omega c plus r minus j omega L by r square plus omega L whole square. Okay. Now taking the r square plus omega L whole square as a common denominator, we will get j omega c into r square. So it is r square j omega c plus j omega c into omega L square plus r minus j omega L. Now we have to separate the real and imaginary part because and at resonance condition what happens is the impedance offered by this circuit is purely resistive. Okay, so what we will do, we will separate these two parts and then the imaginary part is equal to 0. So this is r by r square plus omega L whole square plus j into omega square c L square. Okay, it is from here. Okay, omega square c L square and then minus omega L this and then one more is left, this one, plus r square into omega c divided by denominator is the same, r square plus omega L whole square. Now at resonance, since the circuit is at resonance, this imaginary part will be equal to 0. So this is the only impedance which is purely resistive that will be offered by the circuit to the source. So admittance is equal to r by r square plus omega L whole square, which means the impedance is r square plus omega L whole square by r. Okay, in the question it is given that R is equal to 10 ohms and then L is equal to 100 millihenry and then frequency is given as 10 power 5 or omega is equal to 2 pi into 10 power 5. Now substituting these values for Z, we will get Z is equal to 3.9478 into 10 to the power of 8 ohms. Okay, so this is the resistance that is offered by the circuit, okay, when it is under resonance condition.